process of trying to show this generalized AutoML pipeline API. What I really want to talk about today is just AutoML, not so much as it's been used historically by, quote, citizen data scientists. Early AutoML was all about uploading your spreadsheet. You might be a business analyst or citizen data scientist. But AutoML and what it can do for developers, and where AutoML needs to move, especially in the area of APIs, to make it better for developers and to open some new possibilities for AutoML in the process. So before I start, how many of you are practicing machine learning? I'm assuming it's the majority of that. Yes, great. So how many of you are developers? Okay, cool, majority, great. I should just mention, like, where did this idea, I'm going to be talking to you about this layer over multiple AutoML providers. And you could say, like, why are you guys doing this? Why is Augur doing this? We started Augur because we felt that a lot of other AutoML players were not doing intelligent search, and so the result was within bounded timeframes, they could only get so accurate. So we used some interesting Bayesian optimization techniques to give you better search than grid search. And if you want to talk more, please come visit us in the booth. I'm not going to talk about how much better our accuracy is because of the smart search. But I will mention that we have this challenge of, hey, look, it really is more accurate on your own data sets. So we needed to measure against other AutoML providers, how accurate the winning models were, and we want customers to be able to just take their data sets and actually run it against multiple things, at least on a trial basis, so they could see that it's more accurate. But as we started to build this out, we saw that it was really making, and of course every AutoML provider has their own sort of native APIs, but as we built this sort of high-level generalized layer, it started to enable us and our customers to do sort of more interesting things with AutoML than just what citizen data scientists do, where you upload a spreadsheet and you get the winning model. So our belief as a result of this, if we can make some progress in getting easy-to-use high-level APIs that span multiple AutoML providers, then you can start to build little models for just about everything. Every time you're trying to sort of embed logic in your software, in fact, what you can do is build little micro models, not necessarily huge data science projects that are a business's biggest problem. So we believe that this enables something called AI is eating software, and I'm sure you've all heard the Andreessen Horowitz investment thesis, which is software is eating the world. Every company is a software company, but using APIs for AutoML, you now have a case where if you have an easy enough to use API and the automated machine learning can generate an accurate enough model, you can actually take the step in your software of doing less, building big case statements and if-then-else blocks and complex menus for the users. You can actually build small predictive models that guess what a user might want to do next, or what the appropriate option is in a big, long if-then-else statement. You can also handle models with barely enough training data. You might be sort of wrestling with, geez, well, I really wanted to build a predictive model for this, but I'm not sure if I have enough data to get things accurate enough. Or maybe I can start, but it's not quite accurate enough. Well, if you can embed inside your applications, if you can embed automated machine learning and automate the whole process, not just give me a prediction, which is what most people embed in their running apps, right? They build a model, offline, upload a spreadsheet, build a model, deploy the model, and then they execute predictions in the software. That's commonplace. But the idea of embedding the whole flow inside the application enables you to get started with barely enough training data. Okay, so, and the key thing is that you now can do this for more projects, because you wouldn't build a multi-week data science project to sort of automate decisions inside your applications generally. So whether or not it's with our stuff, AutoML will eat, with Augur, AutoML will eat software applications from the inside out. And I'm going to be showing you this layer on top of both Google and Microsoft's APIs, and they see this. They don't come out and say this when they talk about Google AutoML tables. And by the way, I'm referring not to Google's AutoML last year, which is really neural architecture search. What they just released a few weeks ago was Google AutoML tables for classical AutoML and Microsoft Azure's AutoML. They're very focused on the developer experience to enable this kind of thing. It's a big sea change over things like Data Robot, H2O, which were, if you look at their marketing and their use cases, it's really about getting the data scientists, building these models, and not so much automating that full end-to-end flow. And I'm just going to mention this sort of obscure reference to, there's this, KD Nuggets is a great publication if you don't read it, to talk about machine learning. And this guy Mayo with KD Nuggets said, oh, well, AutoML, since computer programming is about automation, and machine learning is about automating automation, then automated machine learning is the automation of automating automation. So if you're automating AutoML, you're automating the automation of automating automation. Don't worry, I'm not going to do anything quite this obscure again. I just thought it was sort of an amusing extension to how other people have referred to AutoML. So we are automating AutoML. So let's, before we jump into this common layer, let's look at, because some of you might say, like, who needs more layers? I don't want layers, you know? I've picked my AutoML, I just want to program to it. You told me that, you know, Google AutoML tables is very API focused. Great, I can do that. Azure's AutoML is API focused. So before I go try to sell you, I'm not really selling you because it turns out this layer is open source. I think it's worth building the case of, like, first, two things. Let's look at what the general steps are in using this AutoML with the various APIs, and then maybe talk about how we can build a common layer for this. So here's the generic AutoML pipeline. You know, every AutoML vendor, in fact, probably every machine learning vendor has some kind of diagram that looks sort of like this. You know, you start with your raw data, you import it, you typically import it from some, you know, file, CSV, ARFF, you know, SQL table, and then you bring it into some kind of data store that is optimized for machine learning. So there's Hive out there from Hadoop/Cloudera. Google has this thing called data sets. It can seem a little artificial because you say, wait a minute, I had it in a table already. Like, why do I have to bring it from a table or a CSV to some other thing? But that's how just about everybody does it. And the short reason for that is that there's other kinds of metadata that you care about once you start doing machine learning, like, you know, is this a feature or not a feature? Is it a target? What are some other things that I want to know about this thing? Maybe various kinds of metadata that only apply to machine learning that typically you're certainly not going to have it in a CSV, and you're not going to have it in a SQL table, you know, for every column. So there is this process of importing it into some machine learning optimized or data science optimized store. Then you have a training process that's usually some mix of pre-processing and feature processing, then hopefully a smart search. This is sort of our diagram. So you know, at Augur we do the smart search, but everybody's doing some kind of search amongst the algorithms in hyperparameter space. And then you have an evaluate, and that evaluate is a programmatic, if you're talking about APIs, it's a programmatic extension to the leaderboards that you'll see in everyone's AutoML. By the way, for those of you that haven't, how many people have at least seen some AutoML demo in the past? How How many of you have seen some? Okay, so it's about half and half. So please come by the Augur booth, and Jenna will give you a much better demo that I can give of what these leaderboards are. But the sort of like try different machine learning algorithms and show a leaderboard. Everybody does that. It's not a differentiator. DataRobot does it, H2O does it, Augur does it. If you're not using AutoML, I would certainly encourage you to. This talk is not as much like, hey, you should really use AutoML, but like, hey, wouldn't it be cool if you could use AutoML programmatically? Okay, so there's this evaluate step that's the equivalent of this leaderboard of models, and then you're going to pick some model to deploy. And so every AutoML API has this deploy step, and typically that deploy step is either going out to some prediction web service or locally. Google can only go to and this is not a knock on Google, they've built a really nice product there, but they only do the hosted prediction web service. Both Microsoft and Augur and most other vendors will let you have a local Python pickle file or a local Docker container to execute predictions. But there's this generic deploy step, can usually take a while. Evaluate can also take a while. So train is usually, hey, go do some training, and you might have to, depending on what the parameters you set up, that might take an hour, it might take a day. Then there's evaluate, where you're sort of watching and seeing, hey, what's my leaderboard looking like until it's done. Then there's a deploy, and then you start executing predictions, and then typically you want some kind of review process to see how it's doing, right? You executed some predictions, but you need to somehow summarize how your model is doing in the real world, right? Business conditions should change. You probably want some kind of way of deciding, like, this is still a good model or is it not? In fact, this is another reason to automate the whole process, right? Because if you don't automate the whole process, then you may have a model that's sort of stale and doesn't reflect current business conditions, but because if you had it automated, you'd be retraining with recent data. So yet another reason to try to have some kind of generic AutoML pipeline. Okay, so let me pause here. Is there a reason why the evaluate step, shouldn't the evaluate step just be picking the most accurate model? You've got all these models that you try, cat boost, light GBM, super learner, linear regressions, and deep learning models. Shouldn't it always just pick the most accurate model? Can anybody think of any reason why you wouldn't pick the top one on the list? Okay, so the answer is typically, of course, it's the latest exciting buzzword in machine learning is explainability. So you might not pick a deep learning model even if it was more accurate because it might be less explainable. The other thing is runtime cost. Random forest can take a lot of room at runtime. So you won't always pick, even in the programmatic circumstance, you might not always pick the most accurate model. You're going to have a list of models that are doing well, right? And then you're going to pick some model that, for whatever reason, you as the data scientist say, I like this model better. It's more explainable, it's got lower runtime footprint, for whatever that reason is. What's intriguing about Google, and we'll show the Google code, is their leaderboard, they only show like two things, but then they don't tell you what model it is. It's a complete black box. But that doesn't apply in general, so it's actually really important as you think about this evaluate step that what you're going to get is some kind of list of effective models, and then you're going to pick from those models based on some trade-off of, hey, I want something really accurate, but you might want something that's more explainable, and you might want something that has a small runtime footprint. Okay, so let's talk about getting data to the service. So everybody has this step, right? You have to get it from your CSV or your SQL table or your ARFF file, and you just want to get it somewhere. So with Azure, you do have to upload it to some hosted location. And this is not a diss on Azure. I find it a little disappointing that you have to do that. But there's actually a lot of power and detail in their API. They've actually done a really nice job in all the control that they give you. But that said, you still have to go somehow get your local CSV file, your spreadsheet you want to do analysis on, to some hosted location. And then you actually have to write a script for every data file that you would ever want to work with that goes from that hosted location and will give it to the training service at runtime. So I'm sort of whining about that. Let's hope if we decide that it's worthwhile to build a layer, that the layer deals with all this, right? Generates the script, does the local upload. So let's talk about getting data to the service with Google Cloud AutoML tables. So you're going to have to create a data set. You're going to have to then get that data set from, you're going to have to create the data set and get it uploaded. And then you're going to, then Google Cloud AutoML templates will read it from Google Cloud Storage only or BigQuery. And then it's a little strange, it only supports initial import. So you can't like say, hey, just give me the differences. Those are two links that there's a documentation, and then I actually have some links at the end about some nice tutorials about what's necessary. But hopefully if we build a layer, we can automate that whole process of getting the data up to Google Cloud Storage, and maybe even do incremental values. So here's the code that's the sort of overview. Here's the code, and I'm not showing the code to upload the file, but I am showing the code to create a data set here. And you can see we generate a client, and we take the project ID and we combine it with the region, and we get the client location, and then that's sort of the parent. So we then say client create data set with that parent. We give it a display name, and then what will happen is we'll get this the fully qualified data set name back and the data set ID. And this is this whole thing of like, you could say like, hey, why do I have to create this data set thing? That data set is this thing that you can put various kinds of metadata on. You can say, hey, this is my target column, this is my feature column, this is a column that you should ignore. These are different kinds of features. It's a feature column, but it's a categorical feature, and those are all attributes of that data set thing. So even if you don't like my layer thing, hopefully this is a good overview. If you say, no, I'm a Google fan, I want to do everything natively with their API, hopefully this helps you with that process. Okay, now we want to import the data from there into our model so that it's useful. We've created a data set, now we have to go get it. So we can get it from either, we say if path starts with BigQuery, then we say the input URI is that BQ:// Otherwise, it's going to be Google Cloud Storage, and we say the input URI is this set of Google Cloud Storage URLs. And then we call client import data. And by the way, some of you might say, hey, wait a minute, like you're making this like way more awkward than it probably really is. This is actually from a very nice tutorial that Google did about, that I have a link at the end. The slides, by the way, I tweeted out yesterday. That I think did about as good as they could with the API in terms of making it approachable, but still quite a few steps. So that's the process of just getting the data so you can start using it. We haven't done any training. We're just getting data so that we can start to use it, and that's with Azure and Google Cloud. Now, some of you might say, like, hey, why are you doing it with Azure and Google Cloud? Believe it or not, despite the fact that I'm sort of whining about how much code their APIs are, they are very fully instrumented APIs. You can do all of those steps in an automated way, and that's not true of every AutoML player. So I'm actually really excited that both Azure and Google have sort of, Microsoft and Google have recognized, let's make AutoML for developers, not just for data scientists. So here's what you have to, we're done sort of like importing data. Now we want to set up our compute resources so that we can start to do some training. So here's what you have to do with Azure. we're going to call, we're going to get from the environment, this is their sample code, the compute cluster name. We're going to have a set of min nodes and max nodes. They happen to like to get it from the environment. Then we look and see, do we have this before in our workspace? If we do, we say, okay, I've got the compute target, just use it. Otherwise, we're going to provision a compute target. Then what we're going to do is we're going to create a cluster using the provisioning config, we're going to wait for it to complete, and then we're going to say, okay, I've created this compute cluster. We're just trying to get a compute cluster available so that we can run these very time-intensive jobs. So, configuring compute resources. With Google, unfortunately, you can't. They give you 92 N1 standard for equivalent machines used in parallel, which is sort of nice that you get all that stuff, but it is quite expensive. It's $19.32 an hour. And I'm not dissing on Google's lack of configurability, but you'll notice, like, when I show you the layer, that there's no real ability to go say, the only thing you can configure as far as compute resources is the region, which in the beta period can only be US Central 1. So there is a region thing. One would assume eventually there'll be some ability to config the compute resources, because every problem is not the same. If you have a very large data set, you want to have lots of CPUs, lots of memory. If the data set's smaller, you might not need to, and you might be wasting money by doing that. So here is the training run. So we've configured the compute resources. Now we want to train. So we can set all these various options, the iteration timeout. In other words, how every iteration is trying a particular algorithm and hyperparameters. And you say, well, wait a minute, why is an algorithm an iteration? A lot of people use it just for hyperparameter settings, right? So then the idea is that you're iterating, getting a result, tweaking the knobs, iterating, getting the result. So the way you do that there is you have iteration timeout minutes for each iteration, and then you specify the number of iterations. Then it just tries, 30 different times, and it's picking, every time, it's picking a new algorithm and hyperparameter settings. You can actually configure also the overall time budget. So you don't have to do it based upon an iteration, the maximum iteration for each one. You can say, hey, don't spend more than an hour of compute time, or don't spend more than a day of compute time. Then you pick a metric, and this happens to be a metric that's relevant to regression. There's about 5 metrics. You're picking a metric for scoring, for saying, hey, how good is my model? So here we're using Spearman correlation. Google gives you 3 different regression metrics. With Augur, we have a list of about a dozen. You're just picking something for scoring. Most of these products will actually give you all the metrics, but remember, there's a difference between giving you all the metrics for a result and what you use to say this algorithm is better than the other algorithm, right? You have to put a stake in the ground of what to you determines goodness of the algorithm. There's a whole other set that you would use for classification, things like F1 and accuracy. Then we'll go ahead and just go ahead and we'll run the AutoML config, and then we're going to do this experiment submit with that config that we already created. And then we're going to wait for completion, and then we're going to get the metrics. This is the execute, evaluate, and deploy. We're going to register the model. We're going to deploy the model. This actually deploys it out to the cloud. Wait for the deployment, and then we're printing the URI to connect to. So all of this code will work with Azure, and it's very powerful because you can control a lot of things. It's a little bit verbose. Now this is where it gets really not that fun. So with Google, what we're going to have to do is, all we're trying to do is configure the training run and tell it what to train with. The key thing is this model dict here. We give it a display name, data set ID, and then what we're doing is we're playing with the metadata on the table, on the data set to say, hey, what's my target? I give it a budget. The budget is specified in thousands of node hours, which is a very strange way to set the training budget. And then we have a metric. It's set an optimization objective as minimize MAE, very common metric. And then when you're ready to execute your training run, you're going to say create model, and then you're going to wait for that. Well, actually, this, in that code, that actually does wait synchronously, because we could have just said create model, and then we'll call evaluate. This dot result as a function call is going to make it wait synchronously. Probably not something you really want to do in an operational program, but it is showing all the steps. And then when it's done, it's going to give you a model name, and then you can list the leaderboard. So here's an example. When it's done, it has this model, tells you how long it took, and then it gives you how many things it looked at, and then it doesn't tell you what won, which is a little unfortunate. And then it tells you some various metrics on, not just what you asked for, but some other, we wanted to optimize based on mean absolute error, but it gives us the other metrics like mean RMSE, mean absolute percentage, and the R squared. So, apologize, it's a little dry showing those APIs, but let's show something like a little better. I'm not going to go as much into like the lower level Augur API, just in the interest of time. Let's now jump to predicting with a trained model. So here's what you have to do with Azure. Azure is really nice that it gives you both local and hosted. By the way, if you don't want to, if you don't use Augur, I definitely recommend, especially if you're a developer, to use Azure, because there's a lot of scenarios where you may not want to have hosted predictions. It might just be cheaper to have it running locally in your app. But here's the process of requesting a prediction in the hosted scenario. And then on the right side, you can see that what we're doing is we're loading the model. This trained model is a pickle file. And we're importing the pickle, we're loading the model as a pickle file, and then we're just giving it this X vector, X test vector, and we're getting a set of predictions back. It's a little arcane, the X, Y hat stuff, but it does work, and it's actually reasonably approachable. Then with Google, you'll see that they give you example curl commands that you can do, but you also have this prediction service client where you can then take that trained model, right, that we had called that trained project, my project 123, US Central, and then whatever that model name is that you had, and then you're going to call client predict with that full model path, and then any parameters that you have, and the full payload of the values that influence the prediction. Okay, so that was a little excruciating having to show that code. Hopefully you get a sense of, okay, it's great that you can build effective apps with this, but maybe we can do this in an easier way. So hopefully something that you saw from this is as different as these APIs are, there's sort of this common set of things that all these things do. And even the sort of non-developer oriented, I'd call them AutoML solutions, H2O, AutoSKLearn, AutoWika, Teapot, they all have APIs, some combination of their APIs and other stuff that you would need to do. You're going to do all these things if you want to use them. You're going to import data, you're going to train an experiment, right? And that actually should say train an experiment. An experiment is where you're trying all these models. You're going to then evaluate your models and decide which ones you like, generally based on accuracy, but potentially more. you're going to deploy a model, you're going to predict, and then you should have some place where you're sort of looking at, hey, how well are my predictions working? And so it's hard to remember ITEDPR, so we're calling it the PREDI pipeline. It's a little corny. Hopefully the French people in the audience will like this acronym. So what we're saying is, can't we just have like a generic prediction pipeline that we can use over everything? Would that be worthwhile? And this is yet more justification for all that horrible hundreds of lines of code that I was showing you. If I hadn't shown you that, you'd probably say like, why bother? Why do I need to do that? So, but what is the motivation for going and creating this generic AutoML API? Well, no vendor lock-in. You could write to this, and you just stick with that vendor. Like, today we think, Augur has pretty good accuracy, but if you wrote to this generic API, then you could start using, like just change the config setting and use Google or Microsoft. You could actually, ideally with this API, you could actually build a common set of code and run against everybody simultaneously and build models against everybody. No reason you can't do that. May the best accuracy win. The other thing is, I believe, is anybody here from the University of Freiburg or familiar with them? So, you Germans invented AutoML. It's been around for a dozen years. It was invented at University of Freiburg. They actually do the most. They have this contest called ChildLearn that they sponsor, and there's all kinds of stuff coming from them and from the conferences they've organized in academia about how to do intelligent search. And it's not in the industry. It's just not there. Like, I'm not going to name names specifically, but the big players are using something called grid search, which means try stuff. Try this algorithm, set some hyperparameter settings, and they can get away with it because good marketing, and then once you're locked in, you're locked in. So if you have a generic API, then it allows people to innovate. It allows, and not just Augur, there'll be somebody that comes along with some academic technique that beats Augur's accuracy. And it allows innovators, you don't necessarily have to do the whole thing. It allows innovators to plug into specific parts of the AutoML pipeline. Like, you might not like our leaderboard. There's people that are really interested in data science, graphics, and visualization, which is not Augur. Maybe it's, somebody like Tableau, a competitor to Tableau, would create a better leaderboard, maybe with more interesting information about different models. Maybe somebody would do better prediction API hosting. Do things like, have all of the algorithms out there, already preloaded, so you could get more efficient processing there. Maybe better feature pre-processing. Most of the AutoML players are really focused on, hey, let's just try lots of algorithms. Maybe you could have innovation there because you could have people just plug in their one little bit of value into this generic AutoML API. All right, so here's what I'm proposing that we should have. We should have by the way, and you can download this project today, github.com/deeplearninc/a2ml.git. And then you can say pip install -e all, and you will have the a2ml command. So you could do that right now while I'm talking and make sure that I'm not just making any of this code up. And then what you're going to do is you're going to have the new step. This is this predate pipeline, right? New step will create a new project, create a directory for you. If you're familiar with any things like Rails or Django or like these app frameworks, it's going to work just like you're familiar with. You'll do an import, right? Import your data. You will do a train to train your data. Train is just going to go and run train. And of course that might take an hour or a day, right? So you don't want to wait for that. So it's not synchronous, it runs there. And then you call evaluate, and evaluate serves two purposes. It'll tell you if it's still training, it'll tell you the results thus far, and it'll tell you if it's done. And this will work against all these providers that we just described. I should also mention this is open source. Like, you don't even have to tell us you're using this. You can take this, fork it, We'll talk later. I really would like to see somebody that we could collaborate with on this. It's a lot of work. It's something I'm spending most of my time doing. Then you'll deploy once you're done. Deploy a training model, and there's options to deploy it either hosted, whether it's to Azure or Microsoft or Augur, to deploy it hosted, or deploy it locally. And then you'll execute predictions with the deployed model, actually from a spreadsheet of values. And then finally, there's a review stage where you're going to look at those steps. So this is a CLI. I want to reassure you. Those of you say like, oh, that's not really for developers. It's just a command line interface. There are classes inside this project for all of it. So there's an HTML Google class. Google HTML class, Azure HTML class, and a Augur HTML class. I'm hoping if any of you is anybody using another AutoML like AutoSKLearn, Teapot, or H2O? Anybody in the audience using any of those three? Okay, so we would like to see this work against more stuff. So one of the things I'm hoping is get somebody, in addition to using this, getting somebody that wants to maybe work against other AutoML. Okay, so the first step, as we mentioned, is HTML new project. It generates a bunch of files. The most important ones are these config files. And ideally, eventually, it would just be config YAML. And we would have like common options that then translate. There's a fair amount of that out there where we take the config YAML, but there are a bunch of things that like certain vendors do that others don't do. And we didn't want to throw it all into the one config YAML. So here's an example of everything that's sort of common. Well, the project name, and then you can list all your providers. In this case, it's Google, Azure, Augur. We're reading from this Moneyball Kaggle contest, baseball CSV, in this example. We're excluding the columns that we don't want to be in the training data. Actually got this idea from Google, that's what they do with their data set. When they go to train, they say, just remove these columns. That was some of that 100 lines of code they had. But here you just say declaratively, I don't want team, league, and year as predictive things, and I'm trying to predict runs scored. The model type is regression, and the budget is, it's actually slightly outdated. We now do it in minutes as opposed to, so the budget would say 60 now. And that's what it will do by default if you generate this now. And then for the provider-specific config is like, hey, what's the name of the project on the Google site? It could be different. They have their whole, like, you have to create a globally unique name of a project, which is a little weird. But you don't have to set this. If you don't set it, it will get generated when it runs against Google. It will say, oh, I generated this unique name, and it will store that in this Google YAML. And then these things are per vendor only because we have an experiment section, which is all the parameters of the experiment. So we have like what the metric is, and then we have some stuff about the hardware. Remember I said there isn't a lot of configurable hardware with Google. One would assume that that cluster area will get fleshed out as they do more stuff. Ideally, this could, if there was like a consensus on how you refer to metrics, like maybe we could look at the stuff that's in Pummel or PFA and see it, what's the like generic name for metrics, and we could like put this in the config YAML and then set the appropriate things and anything, but we haven't gotten to that point yet. So here's what we do for Azure. We set the cross-validation folds in the experiment, the total time, the maximum number of trials. That's the total time, right? The most it can take is an hour. The most for any iteration, like when you just run one thing, would be 1 minute, what the metric is. So that's all the stuff about the experiment, and then all the stuff about the hardware, like what's the minimum number of nodes, how big a system, how big a CPU. This is the standard D2, V2. And then Azure has this thing about workspace and resource group. that it sets up. So it turns out that you actually don't need to set those last two, in which case when you run this thing, it will actually set those values for you. And then here's what we do for Augur, very similar. We can probably move some of these things into a common thing eventually, but we have the cross-validation folds, the maximum eval time, the maximum number of trials, what the metric is, whether or not you use ensembles. That's one thing we do, is automatically ensemble different predictive algorithms. And then we have like the size of the cluster, minimum nodes, maximum nodes. Okay, so let me just show you a quick demo then of what's involved here. I'm in my handy VS Code, and I'm going to say, I've already done an AutoML new, and here's my test app. It is, and I'm calling it test augur, by the way. This config YAML could be all of the things. This is the config YAML for this test augur, but I just set it to augur because like I wanted to show just augur by itself right now. Otherwise it'll like go do all three simultaneously. It'll import for everything, it'll train for everything, it'll do that all. Probably need to add a command line option, like AutoML-P for the provider, and then I wouldn't have these separate directories. So that will come soon. In the meantime, what I'm going to do now is I can do AutoML, and you'll see it shows me this set of options. I think I'm already authenticated. I have a cookie, but I can do AutoML import. And what it's going to do, by the way, is it's going to grab this /data/baseball CSV file. And what it's going to do is it's going to go and post it. It's taking that local file, it's uploading it, and it's creating a data set on the server. And it's actually setting up a whole machine to start doing AutoML. Okay, I think what I may do is while that's provisioning, I will talk about where we're heading with this. So one of the things we talked about is maybe like there's just a config YAML. There's some work to sort of say, hey, these things on these different, there's a certain amount of like where we've abstracted it, but maybe not as much as we could, in terms of abstracting all the different ways of talking about number of iterations and iteration timeout. So the idea is that as the different YAMLs of the providers get thinned out, you could just put them in general, and there could still be a provider-specific area. Another thing that we'd like to do is have AutoML support for other AutoML providers. If there's any students in the audience or just somebody who's interested in this and you wanted to do it for some other AutoML, we would sponsor internships for it. I'm sure we can work something out, whether it's hourly or like pay somebody to do the implementation. There is a README out there, such as it is. Please let me know what things you want to add to it. I've done it all as a README file. It really should be something like Docusaurus. We want to add other bindings depending on demand, like JS and maybe other languages. And we would like to standardize the API, and maybe that's done through a group like the Data Science Association. If anybody has other suggestions, let me know. So let's go see where we are in this provisioning thing. Maybe I have to stay in this window. One of the things I want to show is that whether it's through Augur or something else, you can see that whether you're using Augur, or whether you're using Google or Azure, like you can actually go at every step and log on to the console for that particular system, and you can see what's going on. So this is actually still provisioning. While I wait for that to provision, I'm going to go to another window and I'm going to run the Google API. And so for Google, I can do, this is this test Google project. So for Google, you can see I've listed the provider only as Google here. I can say AutoML import. And what then does is grabs that local file and it's putting it in a Google Cloud storage bucket. we don't leave these instances of servers running if it's not doing anything, because if you were signed up to Augur, like you'd be paying a lot of money. So like when it's done doing work, we shut it down. So it's bootstrapping now. Let's go back to this. See if this is importing that data into a Google data set. And then once we're done that import, then we can start training it and then run the train. What we've saved here is you having to do the work to like manually put it into a Google storage bucket, right? Because Google won't work off of a local file. It'll only work off of a Google Cloud storage bucket. AutoML is actually like the worst thing to demo because by definition it like takes forever to do. So that's sort of the point of AutoML. Okay, so the project is deploying. You can see that it actually is deploying now. And it should say soon, okay, this thing is deployed. Similarly, if I want to see the stuff on Google, you can go to the Google AutoML console. And it's something I recommend as you use it. Like, eventually you'll trust it enough that you'll just do the command line, but you'll want to like make sure that it really is, that it's running in another window. Let's go back to the Google thing. That is still importing. Okay, it is deployed. So this should come back really soon. Okay, now it's running. So this should finish up. What it's actually doing is like starting a whole, instance of all of the software it needs to do the AutoML. And so once it's running, then we can just call AutoML train, and then it will train and start building a leaderboard. You can see that it took the local file. Now that it's up and running, it was waiting for that to be deployed, and it takes the local file and then puts it up in that hosted system just like Google does. Let's see where Google is on this. So it imported the data, right? So now we're on the Google app, right? And we say AutoML train, right? And it's going to go run a training job. And luckily, it's not going to wait, right? Because remember, these things, the training takes a long time. So it's telling you some stuff about the job. It actually has like a named operation. It updated the data set, right? Because it went, all that code that you saw like is inside AutoML where it like sets the target and removes variables, and you can see that it removed team, league, and year, and you have a long-running operation there that you can use to check that. So now we're going to say AutoML evaluate, and it's going to say, oh no, I'm still evaluating. And it says model still training. And then once it's done, it'll tell you, and it'll tell you what the winning model is. And then you can deploy that. Let's go back to the Augur. So that's actually complete, and I can say AutoML train. Again, same command. And again, if we were doing this in one window, we could actually say, if we had set both Google and Augur, we could run them both. So I'm going to say AutoML train. One of the things that you'll see is different is we're giving you interim feedback along the way. We're actually going to give you a leaderboard, even though it's not done. So this started an experiment, same vocabulary that Microsoft uses with their stuff. And I can now say AutoML evaluate. And it's going to tell us where it is. So it's still pre-processing. It's, creating new features and removing features that are too sparse. It's imputing missing values. It's doing all kinds of pre-processing. But as soon as it's done the pre-processing, it is going to give me a leaderboard. And the leaderboard will initially be like not particularly great accuracy, but it will get better until it finishes its time budget. See, now the search is in progress. Next one should give me a leaderboard. Let's see where we are on Google. Yeah, so that one's still training. It's going to be a bit of a black box. The other thing I would emphasize is, okay, so good. I have a baseline regressor that's very bad. Like, I do not want to deploy this. It's not going to give me good predictions because it's not explaining any of the variance. But oh, now I finally have, let's see, still have that baseline. It will start to get some other models in there, and then as soon as I get another model, then I'm going to deploy that model. I do not have to wait for it to be done. So I've got an XGB regressor, which decent accuracy. This is the model number. And so now what I can do is I can actually deploy that model. So I can actually say AutoML deploy the name of the model, the number of the model, and I can say locally. I can do it either locally or in the cloud. If I do it locally, it's actually going to give me a Docker container. And you can see what's actually pulling down the model and the whole Docker container from the server, so that I can actually do local predictions with that. And this will actually take a little bit because it's actually pulling it down. If we were just doing hosted predictions, then it wouldn't take nearly as long. So it's actually taking it, okay, this is the winner, the model's ready for download, and then it downloads into a zip file, which is then used, you can then use for prediction. So now I can take that same model and I can say predict -m that same model -- locally. Now, one thing, and this will be, okay, so I need to give it a file to predict against. So remember I said we were training against this baseball file? So that was this file, right? So you'll see this same file up on Kaggle on that contest. If we want to predict, we just give it the name of the file we want to predict against, and this, I just want to get one prediction. I don't have any runs scored, I just have these other things give me a prediction. By the way, Google will do the same thing, will operate against the same file, no changes. Both us and Google use this idea of a spreadsheet of values, a CSV, but just leave out the thing that you're trying to predict. So what I'm going to do is now say .. I think I have 5 minutes, / baseball underscore, what did I call the file? Baseball underscore predict. I can call the file anything I want. The key thing is don't give it the target values, right? We're waiting for it to generate the target values. And what's going to happen is it will then execute that. Oh, let's see, what is that? Okay. Let's see. /data. Yeah, here you go. Obviously, we need some better error handling. Cool, and there it is. And so what happens is, if we go to predicted, you'll see that we now have this row. It regenerated that file. That's the green. It regenerated that file. And the last attribute is run scored, and it predicted the number of runs scored. Okay, and let's see if we're ready to do anything with the Google stuff. Yeah, model's still training. Okay, but what would happen is it would then tell us what the model is, and then we can then say, after, we would then say deploy. Yes, we still have a deploy step, even though it's only hosted, and then we would say AutoML predict. So those are all the commands that you need to remember. Okay, so the next steps, I just mentioned. I'm very interested in hearing from you if you would use it, what other things you would like to do. Maybe we can collaborate on, maybe we can do this for you. I just want to point you to these resources here. This is all available at that GitHub repo. File issues there on GitHub. There's a bunch of issues in there. Make pull requests. We'd love to have your contributions. These are some vendor pages that might be interesting to you. All that Google code that I showed is in this. This is like a tutorial on predicting customer lifetime value. It's actually quite a nicely written tutorial. It's a very well-written tutorial with a bit of an awkward API that I had to work with. And then there's another tutorial on Microsoft's AutoML. So I think we have a couple minutes for questions, feedback. Any questions from the audience? Yes?
Are you planning to support any kind of private cloud solution, like scheduling with Docker containers and Kubernetes, or ICT for data, or IBM?
Debugger thing we actually do, we actually generate a Docker container. So that deploy was running inside there. You can actually see the code. It's a Docker run.
Not the supply part, the training part. I can't give the data to the public cloud because it's sensitive. Is there any plan for any private?
Yeah, so I do think, yes, the same generic pipeline could be used for a non-hosted solution, whether it's AutoSK Learn or H2O or Teapot, and then presumably what you would want is have it include Docker containers for those environments just to make it a more predictable run environment. There's no reason why intrinsically this couldn't be done against a non-hosted solution. Yes?
What about Amazon Web Services? Do they support, do they have services for AutoML? Do they have plans to support them?
MSN?
AWS?
Oh, AWS has hyperparameter optimization in SageMaker, so that's a good suggestion. I mean, a lot of the same idea of iterating through things and what's the maximum number of iterations could be done with AWS hyperparameter optimization. One would assume they're also working on like full AutoML where they're picking algorithms and hyperparameters. So that's a great suggestion actually, and it's something that's pretty actionable because it's conveniently in the cloud and you don't have to spend a lot on licensing. So I'm intrigued enough by that I would probably start working on that, but if it's something that's of interest, what I really love is if somebody else said, look, my preferred solution is SageMaker hyperparameter optimization, but I buy off on this abstraction. I'd really like people to collaborate with, because this is sort of like our thing it's like a charitable endeavor for us, right? Like, we actually have our own underlying API and our whole service, and we're trying to keep all that running, and that's why why you have the CEO working on this code, because my engineers are like trying to keep our service up and running. And the lack of test shows that's typical CEO quality code. But hopefully it does provide value for people. And I would hope that if you're interested in that, like maybe we could talk about having you do a provider, an AWS provider, and maybe a lot of that same code that you did for hyperparameter optimization could be maintained once they have a full AutoML solution. Yes, I thought I saw a hand in the back. No? Okay, thanks very much, everybody.